So they're asking us to solve using a sign chart. And well, I'll show you what they mean. The first thing you should do to get a sign chart is to find the zeros of this expression. Find out what it would take to plug in for x to make this side equal 0. Okay, and so to do that, this one's not quite fully factored, okay, because of this quadratic expression over here. We can factor that further. So let's do that. Two numbers that multiply to be positive 4, but add to be negative 4. So how about x minus 2 and x minus 2? Those multiply to be positive 4, but add up to be negative 4. And now that it's fully factored, I guess we could rewrite this as x minus 2 squared if you want. Doesn't really matter. But now we got to identify all the possible zeros. So set this equal to 0 and solve off to the side. So you get 7/2 for x if you solve that equation. So that's a potential 0. And then if we solve this off to the side, we get x equals 2 as another potential 0. So what is this? 2, 4, 6. That's 3.5. This is 2. So we'll order it least to greatest. Here's the first 0. Here's the second 0. 7/2 or 3.5. And to make a sign chart, all they want you to do is to say whether it's positive or negative. Here, actually, it should be between these two. So how can I draw that? I'm going to draw it like this. There we go. Because there's 3 intervals here. All the numbers to the left of 2, we want to say whether that's positive or negative. All the numbers between these two, we want to say whether they're positive or negative. And all the numbers to the right of 3.5, we want to say whether that's positive or negative. So this is probably what the book has for a sign chart. But yeah, you just want to make sure you have, like the switching point is at these zeros, right? That's the big idea. So you can use whatever number you want to the left of 2 in order to test this part of the inequality. So how about x equals 0? If we follow this number line, 0 would be right around here, right? And that's a good number to test because 0 is easy to plug in with mental math. If I plug in 0 into this polynomial, 2 times 0 is 0, 0 minus negative 7. Now look, with the sign chart, we don't care about the exact number, we just care about the sign. So if I plug in 0 into this parentheses, I get a negative number. If I plug in 0 in here, 0 minus 2 is negative 2, so I get a negative number. And same thing here. And now we can know what the sign is to the left of 2, because a negative times a negative is a positive. A positive times a negative is a negative over here. Okay? And then between 2 and 3.5, how about we test x equals 3? So if I plug in 3 into this inequality again, if I plug it specifically into the left side of the inequality, this expression here, 2 times 3 is 6. 6 minus 7 is a negative number. Again, I don't care exactly what the number is. I'm just care about the sign at the end. If I plug in 3 in here, 3 minus 2 is 1, so that's positive. 3 minus 2 is 1, so that's also positive. So negative times a positive is a negative, and then a negative times a positive is a negative. So we're testing points between these zeros. And because it's a polynomial, we know everything between these two is going to be a negative number. Okay? Because it's not going to switch signs again until it hits 3.5. And then the last one, let's try x equals 4. Trying to keep numbers as small as we can. That's something to the right of 3.5. So I plug in 4. 2 times 4 is 8. 8 minus 7 is 1. So that's positive. 4 minus 2, that's positive. That's positive. So the sign to the right of 3.5 is going to be positive. So there's our sign chart. And that's going to help us solve this inequality because the inequality is saying, hey, where is this expression that you just tested positive? Where is it greater than 0? And we just found one spot for this inequality. It's greater than 0 after 3.5. So the solution is 3.5, which is 7/2 to infinity. All the numbers to the right of that 3.5 that we tested. And that's it. Okay? So if this inequality said less than 0, then our solution would be all these numbers. But we have to stop at 2 because at exactly 2, it is not less than 0. It's equal to 0. Okay, so let's switch that around. Let's just pretend this said less than so I can show you what to do there. The solution would be negative infinity to 2, and then I'm going to stop at 2. That covers this part of the inequality. And then I'm going to use union, and it's from 2 to 7/2 to that 3.5. because that's this part. See how we skip 2 because we could never exactly reach 2? That would be the solution if this is asking where it's less than 0.